us have cause to testify, indeed we have been blessed. For as many of us that are here already, we say thank you. For those who are still on their way coming, Lord, we ask that you quickly their steps by your Spirit, that they also will join us in good time, so that we all will share in the blessing of this week. Thank you for answered prayer. Our prayer with thanksgiving is in Jesus' name.
Okay, we'll begin the citation of Dr. Okweoluwa, Adeyemi Okweoluwa. May I please request that you step forward and remain standing as your citation is read. Thank you very much.
This is the citation of Dr. Adeyemi Oluwole Okweoluwa. Adeyemi Oluwole holds a PhD in Sustainable Development and Diplomacy and an MBA in Economics, both from Euclid, an MSc in Industrial Chemistry and a BSc in Industrial Chemistry, both from the University of Ibadan. He is the Deputy Director Scientific and the Head of Business Development at the Institute of Public Analysts of Nigeria, a parastatal under the Federal Ministry of Health, established to train, examine, register and regulate the practice of public analysts and analytical laboratories in Nigeria. Adeyemi is an Economic Development Corporation professional with nearly 3 decades of field experience in chemistry, engineering, management, human capital development and diplomacy, and about 2 decades of consulting expertise in all project and program development phases, as well as collaboration with various implementing and development organizations and agencies, such as the World Health Organization and the United Nations, among others. He has extensive experience working on projects and programs directly in Nigeria and indirectly in the ECOWAS sub-region, India, and Ethiopia. His areas of research and increasing expertise include applying development economics principles to business, financial advisory services and growth, sustainability, agriculture and conservation, health and nutrition, and responsible manufacturing. Adeyemi has several published articles in peer-reviewed journals, and he continues to research the areas of science, philosophy, ethics, and economics relating to the subjects in a manner that assists in understanding the process, its economics, and social impacts. He is keenly interested in solution seeking to understand several factors that cause extreme poverty. Adeyemi Oluwole has supervised science programs in the Institute over the last 15 years in various capacities. Some of his science candidates have gone on to be excellent professionals themselves, a mark that encourages him to do more. He is a fellow of both the Institute of Public Analysts of Nigeria and the Society of Testing Laboratories Association of Nigeria, a professional member, American Society for Nutrition, a senior associate member, Institution of Chemical Engineers Rugby London, a member, Royal Economic Society London, a member, Foundation for Economic Education, Accreditation Advisory Committee, and a member of the African Organization for Standardization. He is an amiable husband and father to numerous spiritual and biological children. And now, ladies and gentlemen, please welcome Dr. Adeyemi Oluwole Okweoluwa.
I want to thank everyone present here this morning. It's quite humbling being in your presence this morning. I would not want to say I understand the existing protocol, but I need to honor this one honor this year. I'd like to honor this morning the president to support and to chair it on, Professor Adeyemi Oluwole, who is a professor of analytical chemistry from the Oba University. Sorry. I'd like to also respectfully also the other presidents of I'm sorry that the name has not got the Professor. Thank you very much. And I'm able pastor here and several students from various institutions present here and other dignitaries, professors online and those online joining us. This morning, I've been given the honor to discuss with us. I would want it to be a bit interactive, and I will speak to my slides, but as well, I want us to follow the trend. I also want us to follow how do I put it? I'll try to balance what we understand in physicality and the spirituality behind the subject of chemistry and its allied courses. And of course, Professor Ogunfowo touched on several aspects of chemistry, that is, chemistry with biology, biochemistry with geology, with geochemistry, with engineering. We have chemical engineering. So chemistry is a bedrock of all the science courses. And I need us to understand that this morning, that if you're studying chemistry or any of the chemical sciences, you are not in the wrong place. I will try as much as possible to give a brief and a feedback of my own career, where I started and where I am today, and how chemistry has helped me majorly to be able to not deviate, so to say, but be able to work in multidisciplinary teams, and also to contribute in subject areas that are not traditionally chemistry. So chemistry gives you that tenacity to be able to learn other subjects much more easier. Okay? Okay. So this is the agenda that I have for us today, and I'll take it very slowly, but also very quickly. I need to know the amount, what's the number of minutes I have. I need to be precise so that I don't waste our time. So the first thing on the agenda is that what does a chemist do? How molecules innovate our world, chemistry beyond the laboratory, the career landscape, become your own boss, chemistry entrepreneurship, transferable skills, and building your future. So I'll be touching on all of these in my presentation as quickly as possible, and I hope we'll be understanding what I'm presenting to us. Okay, what does a chemist do? If you look at this first slide, you'll think I'm talking about computer science or computation or something. But I want us just to take a look at the first slide. Chemists collect data. We process data. We analyze data. We visualize the data. We interpret data, and we communicate it. So I would just like to ask us, before I dive into my slides, that how do chemists collect data? How do we collect data? Research. Thank you very much. So how do we process data? Okay, don't worry. You've tried through research. You collect data through research, because people feel that because you're a chemist, you are not actually collating data. You are actually collating a lot of data as you do your experiments and trying to verify them and trying to find solutions as well. Okay. So data collection, a chemist gathers data from various sources like experiments, observations, simulations, from literature and databases, using various instruments and techniques and protocols to analyze, measure, record, and store this data. So I will just want us to hold on to that. That's one of the things we do. But how does all this, what a chemist do, how does it translate into having great opportunities of employment or great opportunities of finding business? We will understand that as we go along. Yeah. So data processing. A chemist processes data collated from several tests and experiments using what? Software. We can use algorithms or mathematical formulas, as the case to be, to reduce noise, errors, or outliers, and in organizing into usable and insightful information. Now, Professor Ogunfowo did speak yesterday about some certain high precision equipment. He talked about the gas chromatography, mass spectrophotometry. He talked about using infrared spectrophotometry. He talked about proton NMR. I hope I'm not speaking over our heads. I'm not. I need us to understand. So when you use all this equipment, what you're trying to do is that you're trying to process the data you got from your experiment. Probably you have added a chemical A and B together, you got a reaction, but you are not sure of what product you have from those reactions. In processing that data from that experiment, right, you use this equipment and these methods to process that data. I'm trying as much as possible to break it down. I hope you are getting. That is, a chemist does what? The first thing is to collect the data. The next thing we do is to process it. Because you want to communicate what you did, right? Okay, let's go to the next slide, Albert. So we analyze and visualize our data. How do we visualize our data? I didn't want it to be too complex. You will see what the chemist is doing there. We have structures. Sometimes you go into your textbook, you see structures, you see reaction formulas, you try to balance the equation. That is how we visualize what? The data that we've collected, right? We try to bring it out because what you're doing, you are mixing liquids, you're sort of decanting liquids based on their gravity, specific gravity differentials. You're also trying to separate based on boiling point, all those things. We use all these simple principles, separation methods in chemistry to achieve our aim. But after you've done that, what you've separated, this is probably you separated something, it's color green. You want to, what is this green color? The previous one of interpreting the data, you now try to give it a structure. We call it elucidation. I know you may not, but do we have PhD students here or MSc students here? Okay. So the process of elucidation, that is getting a structural information about what you've researched on, is what we're discussing. Okay, now we need to interpret. Even if you've gotten the structure, you need to interpret what is this, right? So interpretation is what is this? Because if you have data, you visualize it, and you have not given what it really is, then it's strange, I think in 1 Corinthians 14, scripture was telling us that if you speak in an unknown tongue, that you need to interpret. Otherwise, speak in your bedroom. Because if you speak, so you have to interpret so that the entire church will profit from it. So prophecy is actually interpreting what you've spoken in the spirit. So likewise, what a chemist does in the lab, you need to interpret it out structurally and with regards to what those compounds do. Otherwise, hold your peace. If you cannot interpret it, if you cannot tell us what it will do, then hold your peace. You have not done anything. Okay? So the last part is to communicate it. I'm sure you heard Professor Gufokons talking a lot yesterday about publication in journals. He has several journals. He has his publications of research in. If you have done all that and you do not tell the world of what you've done, you're wasting your time. You need to tell us that this is what I've done. And a lot of people will want to validate or substantiate your claim. And they will try to redo that experiment you've done in their own lab and find out that, it is true. That's how you get famous. That's how you get renowned. That's how people begin, you gain respect. You don't gain respect in this field we are in, either as an academic or as a professional, by cooking up data or trying to what we call morph now. People can take someone else's work, morph it. We call it plagiarism. I'm using contemporary language for you, so that you now say it's something new, whereas it's not new, whereas it's something that was secretly stolen, and you now added your own skin to it. You understand what I'm saying? So we need to be very careful as scientists. If we must have the theme of our meeting today is exploring global opportunities with a good degree in chemical sciences. For us to do that, we must start very well. I work in the aspects of a lot on ethics. There's a lot of unethical practices going on, both in the sciences and in the social sciences and natural sciences and so on. But if you want to be great and to last long, you must learn to do things the right way from today, starting from today. Okay? So we're not just telling you about how the opportunities that are available to us, but we are also telling you that these opportunities will remain long and last long if you do the right thing the right way. All right? Okay. So I said the power of chemistry, how molecules innovate our world. If you look at the slide, on top there you see you can be a college professor, right? Chemistry and the chemical sciences can lead you to be a college professor. You can be a research chemist. I was once a research chemist for DuPont and did great stuff back then. So you can be a research chemist, a material scientist. Material scientists are those who make new products like your cell phone battery, right? Your cell phone battery, chemists are behind the cell phone battery. Even your screen, chemists did a lot of work on what we call optical emission diodes, right? That's why you can have your screen now, even on your TV. It's people like yourself and myself that did a lot of work. Then we have specialized, unique jobs. For example, like a food scientist. If you're going to be a very successful food scientist, your chemistry background must be solid. If you want to be a very successful pharmacist, or you want to be a successful pharmaceutical chemist, which are those really involved in drug discovery, your knowledge of chemistry must be solid. If you want to be involved in forensic scientists or sciences, your background of chemistry must be solid because you will be looking for information where most people cannot find them, right? I work with, I think the truth is I work with everyone listed here in one way or the other. My institute gives me the opportunity to work with them, the NDLEA, NAFDAC, SON, FCCPC, Customs. We have various issues and challenges that we solve every day. It makes my job very exciting because when I wake up in the morning, I find out that what I did yesterday is not what I'm going to do today. That's what chemistry has presented to me. Sometimes we're in the law court and you're looking at, how can a chemist be arguing with lawyers, right? Because if there is a case of murder, God forbid, or a case where a substance was, if a person was accused that, okay, this substance is, for example, a narcotic, let's say, for example, cocaine, right? That's the one you know most. And the person says, no, it's a lubo. You know what a lubo is? A lubo is yamfa. So how do you substantiate that claim that it's not cocaine or morphine or heroin and LSD and the rest? So the chemist is called in to substantiate the claim that it's yam powder and not it's not heroin or cocaine, as the case may be. So you will find that our work is not just wearing the lab coat alone. Even if you would wear the lab coat, your lab coat can take you to the courts. It can take you to the moon, right? We have a lot of chemists who are working in the science space station now, in space right now. It can take you to several places. So you need to take that foundation very seriously. I remember when I was in secondary school, I didn't joke with my chemistry. It was my strongest course. I knew that if you wake me up, tell me about IUPAC naming, I will tell you. Tell me about, I will tell you about it. Because I wanted to build a solid foundation for my future. And building a solid foundation for your future starts today. It doesn't start in the future. Your future starts today. Your tomorrow is your today. It has become your today. Yesterday you were saying, oh, tomorrow, the 6th, I'll be here. But it's become your today, isn't it? So you need to build up from scratch. If you have a weak foundation, please go back and strengthen yourself. And that's why we're here today. We have secrets of how we studied. We have secrets of how we navigated the storms of life. We can share it with you in 1 or 2 words, and you will not need to spend years going through that. That's what Professor Gunfo said yesterday about mentoring. That is, having mentors to guide you and to lead you in the right way will shorten the time and period for you to get into your own success realm as well. Make use of mentors. Do not call your mentor and say, I need money. Seek for knowledge first. Always seek for knowledge. So, other traditional jobs, we have nuclear engineers, high school teachers, pharmacists, medical lab technologists, pharmaceutical sales representative, environmental consultants. So if you look at on the slide here, you see that we're involved in several things. How molecules save life. We develop drugs. In the food we eat, the clothes you wear, the polyester clothes you wear mixed with cotton is the job of chemists, right? So you need to be excited. There's a certain part that really is heavy on my heart, is that mostly in Nigeria, West Africa, East Africa, the southern part of Africa, they are beginning to produce their own chemicals from scratch. We've not been able to produce our chemicals. We used to. When I was in university, we had Duri chemicals in Agbara. They were making sulfuric acid, sodium hydroxide. We were not importing this. All these were made in Nigeria. And I could remember ExxonMobil was involved in making different types of solvents, both analytical grade and industrial grade. Isopropyl alcohol, methyl alcohol, methyl isobutyl ketones, all the major solvents and we use in organic chemistry were made in Nigeria. We were not importing. I was so happy and proud being a chemist then. And that greatly advanced my career because I worked with several people who were in the industry. I would see the reactions go from scratch, from nothing to something, in Nigeria here. And I was so proud being a Nigerian. But today I can't say it's the same story. Going to Apapa, the factories are shut down. Going to Agbara, the factories are shut down. It breaks my heart, seriously. And I'm still a very young boy. It breaks my heart, seriously. Okay, chemistry careers aren't just about beakers and test tubes. Professor Gufoko broke the ground yesterday on this. It's not just about beakers and test tubes. I started with beakers and test tubes, but today I work more in the area of policy making, right? Both for government, for private institutions, and for transnationals. Now, the issue is that all the experience you will gather over the years, all the experience you're gathering from various aspects of your work will come to be that you will use this various knowledge to solve future problems, right? So whatever knowledge you have today, do not think that you can't use it to solve future problems. The problems may be different, but the experience you've gained can be as a tool that you will use to solve those future problems. And that's why we do a lot of research. We start from common knowledge, which is known, to the unknown, right? There are a certain aspects we call in research, in ethics, that we say the unknown unknowns. That is, you don't know what is known. You don't know what is not known. I hope I'm not being complex. But I'm trying to excite you that why you should step forward. There are things we don't know. We work from what we know to what we don't know. Then there are things we do not know that we do not know of, that you stumble upon. Right? Okay, I've stumbled upon such. So your chemistry degree will unlock a lot of exciting business opportunities for you. So we'll explore how this can be applied in various sectors. Like I told you, I live a very exciting life as a chemist. I must tell you the truth. I live a very exciting life. Coming here today, I'm doing something different. Next week, I'll be doing something different. And it is chemistry that has enabled me to have this opportunity. The opportunity to do different things each time. And do not just look at your course as, what is this among so many things? It looks difficult, isn't it? Chemistry is difficult. Yes, I must tell you. But you can break the back of chemistry if you wish and desire. So in many aspects, okay. So chemistry degree, discover the diverse career paths open to you. Now, we have research and development. If you are the one that you are looking for what is not missing. Who amongst us like to look for what is not missing? There's a lot of money to be made from what is not missing, right? So you focus on research and development. You want to find what is not missing. You wake up in the morning and you say, I want air to be condensed above with a certain type of equipment. It has not been made before. So the first point, when I was growing up as a chemist by my mentor, he said, always carry a notebook along. Always carry your notebook as a chemist. Ideas will drop into your mind. So the first thing is, the great things you see in chemistry and in the world today started as an idea. Someone waking up in the morning, or someone at the breakfast table, or a cup of coffee, and an idea drops into your mind. If you do not have your notebook close to you, it will go and you will never find it again. It has happened to me. It will go and you will never find. You will seek for it, but you'll find. By God's grace. So always, as a chemist, great chemist, always carry notebooks along. As Prof was talking yesterday, Mrs. Osheni was talking, I was taking notes. Professor Ikotun, you're welcome. As she was giving her own brief yesterday, I was also taking my short notes. And I went back to my room, I briefly read through. So you quickly go through. Okay, so you have production and manufacturing. We have entrepreneurship, we have education, we have chemical, petroleum, nuclear, biochemical engineering, forensics, and legal expert advice. A lot of chemists have not found out that you can be a chemist. I have a senior, his name is Mr. He's from Edo State, Akonokai. He's both a chemist, and he went back again to study law. He's one of the few forensic scientists we have in this country that, real balanced. He's a lawyer and he's a chemist, right? Also, he's a member of my institute, all right? So he's a lawyer and he's a chemist. So when he goes to the law court and there are issues of probably poisoning, someone was poisoned, he will talk about the chemistry before the judge and he will talk about the legal aspects, supporting his chemistry. And his chemistry supporting the legal aspect. I don't think he has lost any case. Because he knows, the lawyers know in part, but he knows both parts. So as a chemist, you see, chemistry prepares you, it gives you that grounded knowledge. There's what we call in research, grounded knowledge, that enables you to be able to go into other aspects and fields. It helps you to go into other aspects and fields where they cannot come into yours. We have chemists who are accountants, we have chemists who are engineers, we have chemists who are lawyers, we have chemists who are in various areas. So we start with that and go into other aspects. For example, most of my research these days deal with the aspect of nutrition and the economics behind nutrition. But you may just look at that, the nutrition, the food we eat, what is there? But I will tell you, there's a lot of global agenda going around it, right? There's a lot of interest going around what we eat, what we drink, and what we wear. That's not the topic for today. So that was me as a young chemist back then. I'm still very young. I'm younger now, you know. That was when I was doing a lot of research work for DuPont back then in Mecklin. Worked on several areas of polymers. Most of what you're using today, I'm sure you've heard of Kevlar, you've heard of the one women wear a lot. Your elastic jeans was developed by DuPont, right? So we did a lot of great work, but unfortunately we brought the plant here in Nigeria. I came back and the politics being played on Dangote was played on us. So it's not new today, okay? It's not new, it's something we've been doing in Nigeria. So you can push the boundaries of science and research and development. You can be at the forefront of innovation, developing new products and technologies, right? You can. Do not think that because you studied in Nigeria, you cannot garner international respect or attention. It all depends on how well you develop yourself. You understand what I'm saying? Please understand me that do not see that because you are in Nigeria, you cannot operate in the global economy. I want us to see ourselves today as some of us as students, some of us as postgraduate students, that we can play in the global economy. And The world has become more integrated now. We are more interwoven. We are more interdependent on ourselves. So you could find out that your knowledge of chemistry, there are some certain countries that don't have chemists. They don't have the experience you have. You may think that you are less, but you're not less. They don't have the experience you have, and they will require your services, and then you will go there. You might do your service from Nigeria, or you might be required to go there. So do not just look at yourself and say, oh, it's hopeless. No, it's not hopeless. Focus on your studies, face the challenges, overcome them, and move forward. Okay? So, guardians of quality, the role of chemists in quality control. Now, I'll put this device down. I need to talk more on this. This is a very serious matter. Quality control. If this building, you might give glory to the engineer that designed and built this building. But the issue is that those people, the people who are involved in foundational work, are not usually recognized. Now, can I ask you a question? Why do you think this building is standing? Is it because of the structural engineer, or the materials engineer, or the civil engineer? Why is it standing? What is holding this building up? The foundation. Huh? Let's think. What did you say? The pillars. Oh, the pillars are holding it up. Okay. Because scripture says the invisible things of God are not easily seen and known. Huh? They are seen by the things we see, isn't it? The invisible things. But there's invisible things of chemistry that are seen. So what is the invisible thing of chemistry that is evident in this building now? It's quality. Yeah, that's what we're talking about, quality. I want us to understand the reasons of quality and how you can relate quality to health. You can relate quality to engineering. You can relate quality to nutrition. You can relate quality to materials, to your cars, to cancer, to treatment. I will try as much as possible within the context of the time I have to relate all this. Chemists, great chemists. This building is standing. What is making it to stand? Quality, yes, I know, but quality of what? The materials. Which materials? Cement. Thank you. And who developed the cement? The chemist. So it's not the engineer. The engineer will boast and say the building is standing, forgetting that if the chemist had the wrong formulation or the batch of cement that was used in building the building was not properly controlled, the building will come down. It will come down. So can you see safety in relation to chemistry? Can you see the relationship between safety and chemistry? If you're building ships, you find ships using high rage storms. You might say, this ship is standing because the engineers designed it well. But who made the steel? Who formulated the steel that made that ship rugged? It's chemists. They add molybdenum, they add cobalt, they add manganese to have different forms of steel, right? You have different forms of steel depending on the hardness and all that. So the work of the chemist is very, very important. Intricate. Sometimes we are not rewarded for it. But when we fail to control the quality, the first department when I was in the industry was, call the chemistry department or the quality control. Where are they? We are not making money. Our products are failing in the market. But initially, they will give all the glory to those in the marketing department they can sell. I used to tell my CEO then, I'll look him straight in the eyes and say, if I don't make the products well, your marketers will sell initially, but they'll stop selling after a while. Because if I don't continue to make the products well, it will stop. No matter the marketing gimmick you have out there, consumers will eventually find out that your product is not meeting to the requirements or is not performing. They will stop buying, no matter the marketing gimmick. So you can see how important our work is. Let me quickly, I'm getting signals of time. Yeah. So scaling up innovation, chemists in production. I think Dr. Obadimo will be talking more on this issue of where chemists and how chemistry works in industrial settings, right? But it's what we bridge, what we do. I remember then we have what we call a pilot scale. We have 3 different labs. When I was in the industry, I worked in several industries, a bit in pharmaceuticals, resins, coatings, then food. So what we have is that you have what we call a pilot scale, a lab scale. Then you have what we call a pilot scale plant. Then before you go into large scale plant. So what you do in the lab is that you try to bring those things together to see if it will work. If it works in your test tubes, in your glasswares, then we take it to the pilot scale lab. The pilot scale lab is a miniature structure we design that looks like the big one, but at the lowest cost, because you don't want to put something out there and find out that some of the reactions are not going as you thought. Because I must tell you the truth, we've lost some money while in DuPont. We did some reactions in the lab, we did in the pilot scale, it worked, but when we got to the big one, it didn't go. So those molecules have a life of their own. I tell you, they have a life of their own. So we needed to look and tweak, we call it tweaking the reactions and tweaking the process engineering aspects, process requirements, as we say in those days, to tweak. We now found out that, okay, in pilot scale at so and so level, the reactions will go forward, but at so and so level, that is, as the starting materials increase in mass and in volume, you need to add maybe a bit of more pressure, or you need to reduce pressure. So you start tweaking. So that experience is there. So, but we're all chemists. Some of us were chemists who became chemical engineers. Some became process engineers. Understand. But the basic of everything was the chemistry. Okay, so we optimize production processes, just like I just told you, that tweaking, and we ensure safe and sustainable production of chemicals for various industries. How many of us have heard about green chemistry? We talk about a lot about green chemistry today. How many of us have heard about green chemistry? Okay, green chemistry. It means that we're using safe processes. Okay, let's just give you a very brief story of myself. I wasn't able to tell us all the story. I started my career through, first of all, as an intern in the food industry. I was testing water, wastewater, and everything. That was what I was doing. And then I moved on. During youth service, I was opportune to serve in a company that was involved in water engineering, and they won a World Bank project. Okay, I've been duly corrected. I was doing a sort of work experience. I started out doing a work experience. It was an opportunity to gain work experience. That's what internship means. It's a bit different from sideways. They are similar, but they are different. So I was given the opportunity to have some work experience, also in sideways. I also had that experience. Then I really started my career, maybe I want to say during my youth service, where we started testing water for deep well waters in the Fadama region in the north. Coming back, I also had my experience working with my aunt. She was a chemical engineer. I learned a lot about process engineering from her in practical terms. And from her office, that was a Nigerian engineering technical company. It's a subsidiary of the Nigerian National Petroleum Corporation, NNPC. And she told me one day that there was an opportunity to work for DuPont, which was an American institution, and that she felt that I should apply. So I did apply to the company, and honestly went for the interview, not knowing what I would be asked. Fortunately, most of the questions I was asked was what I had learned practically. That's why it's very important that you do your sideways, and also any opportunity you have for work experience, you use it. do not just say that the work experience, they are not paying me. Then I wasn't being paid. I wasn't paid. So, but I would go. It was my auntie that was giving me small stipends. She was giving me small money as pocket money. But I was gaining a lot of experience. I was even using computer systems that most of my mates have never seen before. So this gave me a great edge. And so when I did the interview and I was called up to DuPont and I passed, I was taken in, and the next thing was I was asked that I was going to go abroad. And I was really surprised that these things are moving so fast for me. I mean, it was so fast. And but how did I get the opportunity, the work experience, which I was not paid for? If I decided that I wasn't going to do that work with my aunt, I wouldn't probably be where I am today, because I wouldn't want to say the rest is history. I did spend a lot of time doing great research work, developing different types of polymers, I would say coatings, also pigment-based systems, There are several things I did and learned that time will not permit me to share in their entirety with us. So coming back home, also did some work with Berger Hedson, now called Berger Paints. Then after a while, I said, after some years working in this industry, I said, that's the power of chemistry. And I said, no, I wanted to change my career path. I said, I don't want to do things so much more in the industry anymore, using chemicals. I wanted to focus more on health and preventive health. And that was how I got into government. At that time, the federal government were looking for experts to help build systems in terms of for preventive health through analytical services. It's not something that is common. That is, you want to prevent health crisis through analytical services. And myself and 3 others were employed into this Institute of Public Analysts, and we started the great future there. And at the Institute, we've been able to network and work with various international organizations globally. We've worked with the World Health, we've worked with UNEP, we've worked with the United Nations Food and Agriculture Organization, UNIDO, Global Alliance for Improved Nutrition, PATH, different, so many of them that we've worked with in our years. But each time I find out I get to use my chemistry in a new way, new experiences. Is either I'm testing things in the lab, either it's food products or drugs or water, chemicals or medical devices. Sometimes we have to audit systems. There's what we call system audits or quality system audit. That is, if we want to find out that is Bowen University doing the right thing, there are specific requirements that we would ask for. And so we also learned how to audit systems, both systems that you use for management, both systems that require technical competencies, both systems that require also what we call metrological services. Metrological services are services that involve weights, balances, volumetric equipment, light, So these are equipment we use to measure and to assure that things are in line. So these are the various experiences I've had working as a chemist. And to tip the ice, to put the icing on the cake, is that all these various pieces of experience now make me and my colleagues in the position that when policies are to be made, we'll be called because of all these various experiences we've gotten, both in agric, both in extension work, testing pesticides, food safety, food security, so many things we've done over the years. And so we have a global view of what is happening. And so when the government wants to take a decision, they will call us and say, okay, come and eat cake, come and have ice cream with us, and tell us, I'm just joking, and tell us what next we should do in terms of the direction we should follow. So the career path a chemist has is so wide, and its application is encompassing. How do I mean by encompassing? It's extremely wide. From what you're sitting down to what we've taken, soft drinks, to the bottles we use in packing our water, to hair extensions, eye drops, anti-malaria drugs, name it. Even to computer systems, batteries, the eye lenses we use are all developed and made by chemists in various fields. So the career of a chemist does not end in the lab coat like you saw in my slide. It's not about being in the lab alone. You will be in the lab sometimes you are out of the lab. Sometimes we are on the road discussing with politicians. We're discussing with politicians. And the application of chemistry goes beyond just molecules, right? It goes beyond molecules. It also goes into the fact that you can think out of the box to make advice, even politically make advice to those who ask you or who ask for your consultation. So the life and the career path for a chemist is so wide and deep. You will determine what you want to achieve. But I must also tell you that there's a lot of hard work involved. It's not impossible. If it was possible for me, it's very possible for you. And one of the things that chemistry teaches you, or any of the chemical sciences teaches you, is to work hard. You learn to work hard. You learn to increase the capacity of your mind and of also your thinking, your critical thinking abilities is improved. Whether you're talking of mathematics, we did all manner of things mathematically. If you're talking of statistics, we're also involved. A chemist is involved in statistical computations. If we talk of biology too, biostatistics, chemists are involved in it. Pharmaceuticals, pharmaceutics, chemists are involved in it. Drug discovery, discovery of new chemicals, discovery of new processes, chemists are involved. Textile, paints, coatings, aviation. You know that our aviation industry makes use of a lot of chemists. There mustn't be a single drop of water in your aviation fuel. And even if there's water, it should be at the most minimal level. Because water in the tank of an airplane will form ice and it will clog the engine and the engine will stop to work. Now, do you know that we don't use air? Chemists are involved in aviation. You think at the airport, all the technicians you see, they're engineers. Some are chemists. You know that we don't use air in the tires. We use nitrogen. Why do you think we use nitrogen in airplane tires? Why? You think it's air. Why do you think we use nitrogen in airplane tires? Okay, we're still thinking. Because of time, we use nitrogen because before an airplane takes off, the frictional forces on the tires is so high that most times the temperature of that tire is well above 100, about 120, 130 degrees centigrade. That's how hot airplane tires get before taking off and when they land. So at such temperatures, if you don't have nitrogen inside, the tires will begin to burn from inside and you'll have fire. So that's why it's a mixture of, I think, about 60-40% nitrogen in air. So you're creating an inert atmosphere within the tire so that the tire does not what? Burn. Nitrogen does not allow combustion. It's a very good, we use nitrogen in several reactions to prevent oxidation. Most of reactions, we don't want air, oxygen to be involved. We put it under a nitrogen blanket, and we know that that reaction will go without going into oxidation. So nitrogen is used. So you can see that your work can also be in the aerospace industry. Aerospace meaning that you're dealing with planes, spacecraft, and so on. The spacecraft that goes into space is chemists that developed the rocket propellant that takes spacecraft into the space, or to the moon, or as the case may be, or to launch satellites. You develop the propellant. So there's a massive amount of prospects for chemistry. There's also natural chemistry, natural product chemistry, where you can go to the field here, and maybe my sister here will discover that pawpaw leaf can cure diabetes. It's there looking at us. Probably you'll be the one that will say, let me just take this leaf and check. and you do some work in a lab and found out that, this thing helps to cure diabetes. It brings back the pancreas, it gives you back life. So this is part of what you can do as a medicinal chemist. So we have medicinal chemists, we have what we call fine chemical chemists who deal with perfumes. That sweet smelling perfume you use on your body, the perfume you use in your, the body sprays, the aerosols you put at home are all developed by chemists. They are sweet smelling esters, as we call them. So much that if we begin today, we won't be able to end. And so you will decide where your interest lies. And today we have an interconnected economy. That is, the economy of Nigeria is interconnected with that of the US, is interconnected with that of Germany, is interconnected with that of the UK, South Africa. The economies are global, such that you can be here sitting down, my sister, sitting down here looking at me. You can be solving problems in Botswana, in South Africa, in Niger, in Korea. You'll be here giving them solutions. You can even be in here, in your lab here, doing experiments to give solutions to problems elsewhere. So you do not necessarily need to leave where you are located to give solution in another place. This is what is happening today. There are video systems, internet systems that you can be conducting an experiment, be teaching people who are far away from you, even in another country. You are teaching them from Nigeria. So you can see that you can be a global teacher, not just a local teacher. You can be a global teacher. That will be your profession. That is, you are involved in teaching, in education on a global scale. And we have businesses that are taking advantage of this, that I see them on the internet asking me, would I like to lecture in some places? Would I like to do it remotely? And so on. So you can see the global market is so wide that as a chemist, you can apply yourself without even leaving your location. So that's on the education basis. Research and development is somewhere that it's something we've discussed a lot. And there's so much to be researched on. The research and development can be broken into several aspects. Like I told you, medicinal chemistry, you have polymer chemistry, you have drug discovery, you have pharmaceuticals, you have pharmaceutics, right? You have cosmetics. Cosmetics deals with our hair cream, body cream, lipstick, eyelashes, etc., etc. This is also a field in chemistry that you have cosmetics. You have medical devices, pacemakers and drugs that help to maintain the body's stability. This is a different form of drug discovery in itself. Shoes that we wear. The soles of our shoes are made from different types of polymers, rubber and plastics. The air conditioning system, the refrigerant used in it, the cooling refrigerant is made by chemists. Your car, the petrol, the truck, the diesel, home, the cooking gas, right? So you can see chemistry is beautiful. Your lubricating oil in the car, the cooking oil we use at home has been hydrogenated or dehydrogenated by a chemist, as the case may be. So you start off at a certain aspect, maybe with a BS in chemistry, and you go into the job market. There are so many career paths you can navigate into. So gone are the days they will say a chemist's job is in the classroom. Fine, yes. Even in the classroom, it's so lucrative now. I take a lot of training sessions. I take a lot of training sessions as a chemist. I take a lot of training sessions online. That the people are not even Nigeria, some are in Europe. And we train them from Nigeria. So if you say education is not for me, wait a minute, hi. You may be wrong. Gone are those days that you say education is not for me. It's a very lucrative route to teach the next generation knowledge and to pass knowledge down. So this is what chemistry offers to us. If you talk of medicine, pharmacy, without chemistry, these courses will not exist. So I urge us, I know that some of us have doubts, but I'm here this afternoon, yes, to douse our doubts. Don't worry about it. A chemist will always succeed. Be sure of that. You will always succeed. I've not seen a broke chemist before, except you decide that you want to be broke. I've not seen one before. Very soon, the world will seek for you more, because the amount of chemists, number of chemists in the global market has reduced considerably. Most of us, we are getting to the age of, we are leaving the scene. We are not producing enough chemists to take over from us. We are not producing enough. And we need chemists in every aspect, even in the electrical industry. If you go to Kainji Dam, you find chemists there who have a lab, who test the water. They test the water before it gets into the turbines. They test the water that comes out of the turbines. Why do you think they must test the water before it gets to the turbines? If the water is loaded with too much of nutrients, it will clog the turbines. The turbine will get clogged. There might be sedimentation, right, or precipitation of these nutrients, which will clog the turbine. So chemists will take samples of the water before it gets to the turbine. They will also take samples of the water when it comes out of the turbine to see if there's any leakage of lubricant. Lubricant is what makes the turbine turn, you understand? They lubricate. So if it's leaking, if there's any sign of lubricant in the water, that means the turbine will soon go bad. Okay? So this is the job. We have chemists in the power generation industry. Yes, there are chemists. In the railways, we have chemists there who test the diesel the trains use. The diesel, the water that they put in the train and all those things. There's a chemistry department, they're active. If you go to the railway, Lagos State Rail, the Federal Railway's main stations, you will find chemists there. You'll be surprised. I'm sure you're surprised. You're looking at me. Also, the chemists actually work in the railways. Yes. I've told you about the chemists working in the airplane and aerospace industry. Yes. In the rail system, yes. Trucking, yes. Shipping, yes. If you go to the ports, you have chemists who test water, right, for leakages from ships. If ships are leaking oil, they will test. If you are leaking too much oil, they will fine you. So shipping, yes. Aerospace, yes. Railway, yes. Trucking, yes. Refinery, yes. Education, yes. Agri, thought you say yes. Agro-allied, yes. Cosmetics, yes. Medicine, yes. Pharmaceuticals, yes. Textile, yes. Let's continue now. Nuclear, yes, you find chemists there. Well, what else? Computer, yes. You find chemists also. So the field and width of application of chemistry is deep. But I know so many of you are scared that, how will I be drawing structures? How will I understand the structures? When we two started, it was like that. It was as if it was magic. But the more you exert yourself, the clearer the things became to us. And it became easy. It became part of us. Now, if you draw structures for me, I just look at it. I say, okay, this is benzene ring. This is a 5-ring compound, a 6-ring compound, alkyl groups. It's become part of me. You understand? It's become part of us. But we need chemists in Nigeria a lot, especially in Africa. We are not developed yet. We need you to help us develop. We need you to help us develop our green technologies. We need you to help us mitigate climate change. We need you. You are the next generation we're passing the baton to. We need you to take hold of this profession and lead us onto what?
Eh? Jesus said, lead us not into temptation, right? So you lead us onto righteousness, the next step, the next level. Okay? So what am I saying is that I remember I was sitting there. You know, you can do time travel in your mind. I remember I was like you. I was like sitting there, and someone was talking to me many years ago, just like this, as we're sitting down. And today, I'm doing what that person is doing. Can you imagine? I just remember now sitting down when educators will come to advise us. We call them course advisors. When we go on an excursion, we have people telling us we'll sit down, do the excursion. They'll tell us, be study chemistry, you can apply this. I was sitting down there. And today I'm sitting down here. Tomorrow you'll be sitting down here. But one thing I can assure you, you can't go wrong with chemistry or the chemical sciences. When I mention chemistry, please, I'm not mentioning chemistry as a subject alone. I do mean the chemical sciences, including the engineering, biochemistry, biochemical engineering, all those. That's what I mean by chemistry. You can't go wrong doing those subjects. Today we have specialized drugs that are made biochemically. They are not synthesized using chemicals. They are special fungi and bacteria that are mixed together to produce those drugs. A lot of drugs that we take, if you look at where it's produced, you won't like it. The smell, it's smelling like poo-poo. Where the bacteria are working to produce the drug. When you take this, the odor is so bad. You say, is this where this drug is made? Yes. What comes out from that bad smell is purity, something that can help heal the body. So this is what chemists do. We discover new pathways, new routes in making the same product even better. Sometimes in some industries, the terms of reference they have, it's not like they want to produce something new. The terms of reference they give them is to produce the same thing in a better way. Right? If you remember Dr. Obadimu, he was talking about process optimization. Right? Process optimization involves that you are producing, for example, let's say paracetamol or Panadol. They now give you the task, can you make it cheaper and better for us? That's process optimization. So there are companies, organizations that employ chemists, especially chemists, to look into this process, to find new ways of doing it without even harming the environment. So this is the next move for you. This is where the new money is. I want to call it petrodollar. That's where it is. Producing the same product cheaper and more efficiently without harming the environment. This is your job to do. We have done ours, but you can do it better. You can find new routes, whether biological routes or chemical routes that doesn't harm the environment, and give us a solution. And tomorrow I see in the news, maybe when I'm like 70, I know this boy, I saw him in Buen 2024, he's winning a Nobel Prize. I said, I know, that lady, she's a pharmacist, she just discovered a new drug, cheaper. This is how it starts. Great people sat down like you sat, Einstein and the rest, Newton, they were just like you, sitting down, listening to those who were ahead of them, encouraging them. And it took the mantle and ran with it and became people that we are talking about till today. So it starts here, it starts here. Nothing special. This is how it starts. It's not something that you are in your dream, you just wake up, boom. It starts here. All right? So I urge you, have that dream, have that passion. Develop that dream to want to say, I want to make a change in my generation. I want to make that change through chemistry in my generation. And honestly speaking, God will give you that grace and the knowledge to make that change because it's a sincere one. And you can do so 5, 6, 7 years from now. We will hear of many of you. But I want to assure us that we need you to take the mantle from us. We're having too many few chemists globally. Too many few chemists. Because chemistry is a bit tasking, no doubt. But if you face the task, you overcome it, you become great. I'd like to thank you for listening. And then if you have no more questions, you permit me to sit down and then close for the day. Okay, you have a question.
Now my question is, all these chemical symbols are transferred under which in chemistry? All this chemistry, benzene, benzone, all these things are transferred under which aspect in chemistry?
Well, we won't say they are classified under a certain subject because every aspect of chemistry has symbols. If we're talking of inorganic chemistry, we have the nomenclature we use. For organic, you have its nomenclature. For physical chemistry, we have also some nomenclature that is used. But everything in research, we call it, to determine the structure of a compound, right, we call it elucidation. Elucidation means determining proper structure, right? That's what it means. So we can't really say it's a subject on its own, or it's a department, or it's a course of learning on its own. Though there are several courses that you take in a university that helps you determine, like symmetry. There's a course called symmetry, point symmetry in chemistry, to enable you determine if a compound, I don't want to go into the chirality, if it's chiral or not, that is, can you have a mirror image of that compound or not? There's all called chirality in chemistry. It's about elucidating the structure. So structures in chemistry do not have a particular course number. It cuts across all the subjects or areas of chemistry. But if you're talking of inorganic chemistry or organometallic chemistry, you can't say organometallic structure chemistry. No, it's all structural in chemistry, right? Okay. Okay.
Thank you very much, sir. Bringing agricultural science, food security, and climate change to context, we've been having a lot of debates on organic and inorganic things we use in agriculture. And I would like to know how chemistry can help to balance this and bring a level playground to it.
Thank you very much. I'm so happy that you're running an undergraduate or postgraduate degree. Postgraduate, thank you. You're going to provide the solutions for us. You'll be the one to provide the solutions. The first thing you need to understand is, where are the problems coming from? What are the challenges? Because if you don't understand the problem statement itself, you will not be able to provide solutions. You understand? Now, one of the challenges we have, if you look at, it's common in literature, would say we have excess carbon dioxide being produced. So that is the problem statement. Now, you would ask yourself as a chemist, what processes are producing high emissions of carbon dioxide, so to say? Is it bush burning? Is it probably a refining process? Is it an alkylation process? You know, I'm just giving examples like that. You look at it as a chemist and say, how can you look at the chemistry behind the reaction, and you can say, how can I still get to this product without CO2 being produced from this reaction? That's the first step to start. You start in your notebook. First, it starts with an idea that, okay, this is the problem statement. The next step you need to take is that you look at the pollutant that is coming from that reaction or steps of reaction. Then the next step is to say, how can I get to the same product without producing this pollutant or side products, as the case may be, right? So that is how we start. Now, I can't say this is a solution now, because there are several solutions already that are being implemented. One is to look for newer processes, like I did say about green chemistry. Look for other processes that do not produce these pollutants. Then there are other cases that chemists have found out that at a certain threshold, beyond this threshold, if you increase the use of pesticides or rodenticides, it does not have any more positive impact. Research has shown that at the minimal level, you have the same effect, maybe by using, let's say, 10 ppm. If you use 10 ppm, you get the same effect as using 20 ppm. So the excess 10 ppm is not really required. It's like some farmers, when they see some pests on their farms, they use the pesticide. They now come again and use it again. No, it doesn't increase the effectiveness because pesticides takes a while to work. Putting so much doesn't increase. What it does, it increases the amount of pesticides in the ecosystem, whether in the water or in the soil or in the air, and it gets back to us and it resides in our liver and causes all forms of diseases. So we found out that after a certain threshold, you don't need to use more. It will work. So that's part of our job as chemists, finding solutions to minimize effect of pesticides or mitigation processes, as we would like to call them. So also you can think through of finding alternative materials that are benign. Benign means that they are non-harmful. So, but it will take you doing a lot of research, right? I can't tell you that the solutions we have today, they are the best. You are able to find newer solutions that we already have. Like the use of polymers for when there's oil spillage. There are some certain polymers, there are some certain types of detergents that are used to disperse the oil spill, such that it doesn't kill fish, it doesn't kill birds. Then there are certain types of polymers that are used to mop them up and extract them from the water. It's extracted and not destroyed, but it's extracted and now tanked. That is, you are able to get back what's spilled back into where it ought to be. So these are new methods that are being applied, and chemists are at work doing all this. Right. But since you're doing your research work, pick on one of the challenges, pick on one of the problems. You're not a chemist. Okay, you're an agriculture. Okay, crop protection, good. You need the chemistry for your crop protection. But probably you're finding that you're having newer, is it maybe nematodes, or you're having newer insects that probably you use some certain pesticides, it's not working on them.
This is the citation of Dr. Clement Olusegun Obadimu. Clement Olusegun currently serves as a senior lecturer in chemistry at Akwa Ibom State University, safety and risk supervisor in marine operations at ExxonMobil, and director general at Mentos Tower. He is renowned for his expertise in environmental chemistry and impact studies, focusing on monitoring and sustainability, toxicology and pollution studies, and statistical and modeling mechanisms. Additionally, he specializes in analytical and applied chemistry and safety and risk management, addressing the effectiveness of safety management tools, occupational and operational safety, and safety in both office and home environments. Clement Olusegun received his PhD in analytical chemistry with distinction from the University of Calabar in 2010. He also holds an MSc in analytical chemistry from the same university, a PGD in applied chemistry from the University of Lagos, and an ND in drug and chemical technology from Lagos State Polytechnic. In his academic career, Clement has initiated a chemistry research group with graduate research assistants at the University of Uyo's Institute of Health, Safety, Security and Environment Studies, where he has been a visiting senior lecturer since 2017. His teaching portfolio includes courses in analytical chemistry, environmental chemistry, and various specialized subjects relating to the oil and gas industry. His industrial experience spans multiple roles at ExxonMobil, including Marine Safety Supervisor and Operations Lead. He has facilitated safety communications programs, significantly reducing incidents, and has been responsible for overall marine and logistics safety performance. His previous roles at ExxonMobil included Laboratory Team Lead, and chairman of the Waste Management Committee. In addition to his academic and industrial contributions, Clement Olusegun has held several leadership positions, including head of unit for industrial safety and risk management at the University of Uyo, national president and chairman of the Governing Council for the Chartered Institute of Corporate Mentoring and Coaching, and founder of the research group Environmental Science Explorers. He has been recognized with numerous awards and honors for excellence and selfless service from various organizations. He is a prolific writer and mentor, impacting his community and nation positively through his literary contributions. Clement Olusegun holds several professional qualifications, including fellowships with the Institute of Chartered Chemists of Nigeria, Mentoring and Career Development Institute of Nigeria, Occupational Safety and Health Association UK, and Chartered Institute of Mentoring and Coaching Nigeria. He is also a certified professional life coach and a member of various professional bodies, including the American Chemical Society and the Nigerian Chemical Society. And now, ladies and gentlemen, please welcome Dr. Clement Olusegun Obadimu.
I'll quickly be speaking on exploring the great opportunities in industries with a good degree in chemical science. I summarize that to mean unlocking your potential as a chemist. I'd like to give a brief overview of the chemical sciences field and the importance of exploring diverse opportunities. I'd like to apologize that my slide is typical, unlike me, and because of my time, I didn't have time to conclude because I'm also working and I have to make up time to present this. So if I cannot send it immediately, it's because I need to still work on the slide to meet up my own kind of presentation slides. The overview of the chemical sciences field and its versatility, I'm not going to be reading, just wanted to let you know that the entire chemical science field is so vast. At a particular time, you will remember, in the, call it 18th century, people who went to the university those days, that is 17 something, 18 something, they just study science, period. Over a time, sciences begin to widen up and they begin to study physics, chemistry, biology, and that begins to widen up. Today, people are no longer just studying chemistry. You have somebody just studying purely biochemistry, somebody studying purely environmental chemistry, even at the first degree. So the knowledge is becoming so vast that the study of chemical sciences has widened in such a way that we have analytical chemistry, and there are universities who studies just analytical chemistry at the first degree. We have organic chemistry, inorganic, physical chemistry, biochemistry, materials chemistry have started coming up, environmental, as I mentioned, and we already have what we call theoretical chemistry, where computational modeling and simulation normally evolve. I'd like to also quickly let you know that the study of chemistry applies and can have applications in such field like healthcare. And that has to do with drug development and medical research. Let me quickly tell you that we are still having a continual drug development and research. And we have energy. Chemists are also found in energy, fuel, cell, batteries, renewable energy is coming up now. Even in the environment, pollution control, climate change mitigation, whereby we have carbon sequestration and many other things that chemists are doing so that we can be able to help solve the problem. In materials development, at a particular time, you realize that we're using bottles to get our drink. Later, they are now using plastics. And as we speak, because of the plastic waste that cannot be handled globally the way we want, there is a research going on. What kind of material can we be using to bottle our drink so that it can be a biodegradable material? So there are so many work waiting for all of us who are chemists. in food, in pharmaceuticals, and I mentioned that earlier, drug design, synthesis, and testing. Biotechnology, where we have genetic engineering and biofuels, forensics, cosmetics, aerospace, the knowledge is just too wide. I like to note, primarily, chemical science is essential for so many things. One of them is addressing global challenges, whereby we have climate change and sustainable energy. Not only that, improving human health and quality of life, developing new technologies, understanding and protecting the environment, advancing our understanding of the world. What is the importance of these diverse career opportunities? I'd like to quickly let you know that when you study chemistry, there are so many things that are widening, that are up there. One is helps you to uncover hidden passion. You may discover new fields or roles that align with your interests and skill, leading to a more fulfilling career. Many people don't even know that whenever they study chemistry, they just think you're only going to become a chemist, you're only going to sit down in a shop called chemist shop. No. As a matter of fact, chemists are not those who are required in the chemist shop. It is actually those who study pharmacy or pharmacy technicians who dispense drugs that are expected in those places. However, when you explore career opportunities as we are doing right now, it broadens your perspective. Some of you just study chemistry, you don't know. And it gives you an exposure to various industries and roles that helps you understand the interconnectedness of all the fields and fosters a more comprehensive understanding of the job market. If you are able to understand what we are discussing today, it will help you to enhance adaptability. Also, I can move from industry here and move to this industry and go there just because you now have a wider scope of what these career opportunities offer for you. It increases networking possibilities, venturing. As a matter of fact, I have worked in few industries as a person. I've worked in teaching. Chemistry education is also an industry. I've worked in a pharmaceutical company. I've worked in, I'm presently working in oil company and so many other particular companies that uses what we call, and I've been hired to come and do one job or the other. I'm also presently working in research because I lecture in the university presently and I also work in industry. Now, it develops the opportunity to transfer your skill that you have developed in a particular area and into another one. It reduces career stagnation. Now, if we give you this openness to career opportunities, exploring opportunities, you will realize that you cannot just stay in one place and say you are comfortable. No. I remember when I was a teacher, far back about 30 years ago in secondary school, I was always going from teaching in the afternoon, in the morning session, in the afternoon or evening, I'll be going to a particular laboratory as their part-time laboratory analyst. Combining these two makes me to realize that my career is not just going to be only teaching, but it's going to be something wider than that. It fosters the creativity and innovation, yes, and it improves decision-making now that you are exposed to so many opportunities for having career, what we call chemical science degree. And it prepares for unexpected opportunity. Bam, all of a sudden, they said there's no more job in oil industry. Because I've been lecturing in the university, I'll pack my load immediately straight to chemistry department of any university, and I'm there. Oh, they say they are having these challenges in what? In the university. They have locked them down for a long period of time. No. I'm not going to stay there and be waiting for, because of strike of lecturers and there's no salary. I've packed my load again. I'm already going to another place whereby they are needing and requiring all the skills I have acquired over time. Remember, exploring diverse career opportunities is an ongoing process. You need to stay curious and be open-minded and continuously seek out new experience to fuel your professional growth. I'd like to quickly say there are traditional chemical sciences career, and they can go in this form. Research and development is a research career. quality control and assurance. I will be talking about these two. The other ones I won't because of time. It's so wide. When you ask me to talk about chemical sciences degree and the industrial, it's just too wide. This is for under traditional chemical science career that we do. Now, apart from this area where people normally work in the research and development companies or quality control and assurance or process development and optimization, I will explain some of them. Because when we say process control, process development and optimization, too many things are involved and we need chemists. All of a sudden, we were using a particular substance. Well, when we talk about process development and optimization, in a particular company, you have been producing a drug and you've been using a particular process and it's been taking a longer time for you to produce it. Because of that longer time, and the production, either production pharmacist or the MD suddenly said, can't we do another thing that can make us shorten this period? Somebody said, it is because of the chemical, our raw material we are using, that is taking that longer period. Can we go to the research department and see if we can come out with something better? Now, that has combined two careers. The research and development department, they will be looking at which other alternatives will be useful. Then, when you are able to get it, you will be able to do process development and optimization to reduce the time, to reduce the cost, and guess what? You're going to make more money because of that approach you have done to. So when we talk about process development and optimization, it's so wide. There was a particular time in the place of work, they were doing what we call bottle testing. Bottle testing has to do a principle whereby they are testing on the emulsifier. Emulsifier means, demulsifier, a particular chemical they use to break the emulsion so that that particular substance or emulsion can be useful for whatever purpose they want to use it for. Now, they were now using demulsifier. Now, there is a particular demulsifier they were using that it was so thick that they find it difficult to be able to pump using the pump they were using. So I was in the lab and they contacted us. All of a sudden, they said, let's see how we can do and get this pump to pump this. The demulsifier couldn't be pumped. Why? Because of the viscosity, the thickness is so high. So we needed to start thinking, what kind of substance is this? What kind of substance is this company? Is this chemical? It was then we realized that chemical has more of OH group, alcoholic group. So okay, let's see if we can use a solvent like alcohol, something of OH or phenol, to be able to mix with it and reduce the viscosity and the thickness. It worked. But there's also one other thing. With the efficiency, effectiveness, and efficacy of that substance still remain what it's supposed to be, we needed to test that particular one. When we finished that, we said, no, hold on. It means we are going to be buying alcohol or phenol to mix with this substance before we can pump it. Somebody said, hold on. The water is also having OH group. Can we mix this chemical with water and see if it will get the same effect? Bam, and the thing worked. Specifically, I was in the lab. I was the lead person. I was the one that suggested that water. And guess what? The thing worked. And all of a sudden, somebody somewhere said, sir, why don't you just bring drum of water and sell it to the company? I said, no. They can always get a tap of water from here. And guess what? It solved the whole problem. That is chemical science degree. And we were able to combine research and development. We were able to combine process development and optimization. We were even able to combine quality control and assurance right there. So that's why I said there are so many so many work or career involved in traditional chemical. This page alone has 4 areas you can work. You can be working in the career research and development. You can be working in the quality control and assurance. I'm going to explain that one briefly. You can be working in process optimization, whereby you are just changing the amount of material they are using to get optimum. For instance, I was able to get paracetamol. I was working in a drug company, and they were what? We were producing paracetamol. There's a particular paracetamol powder we brought. the percentage purity of that paracetamol was about 94%. That means to be able to get Panadol or paracetamol tablets, we need to increase the amount of the what? Of the raw material. Then when another material came, the percentage purity of that paracetamol was 99%, meaning that the quantity of that material required will be reduced. Who do you think is involved in calculating all these things? Both the production chemists and the production pharmacists, who were all there for the purity of this. This is the amount of quantity you need to produce that paracetamol. For this one, that is what we call you are optimizing process, and you are doing, there are so many things involved. The same thing with regulatory affairs and compliance. Some people are working in NAFDAC, some people are working in other areas to ensure people who are producing some of these chemicals, they are compelled to ensure that they meet up the regulatory compliance. So traditional chemical science career are these four. We also have other careers that is also coming up: emerging fields and industry, renewable energy and sustainability. Are you ready to leave the university and enter into any of this one? Biotechnology and pharmaceutical development. Somebody said that I did not study biotechnology or genetics. I did not study pharmacy. That is what you need to know, that as a chemist, you are necessary, you are needed in this particular area. Material science and nanotechnology, I've mentioned part of the material science for you, whereby a particular material is being used, i.e., for instance, bottling company. Somebody said, can we begin to change the material to something that is more biodegradable? And you will need a chemist to help. Even environmental consulting and management. These are the emerging fields and industry. Interdisciplinary application. Even chemists right now can work in data science and analytics in chemical research. Oh, wonderful. One of my former students is presently doing PhD. He was teaching and they were paying him $40,000. I was annoyed. So are you telling me for the whole 4-year program that you have done, what you are going for is what? Just to be collecting 40,000 naira. At a particular time, I have to be very mad and told him, stop that job immediately. Thought I was joking. I said, hey, come, let me teach you SPSS, Statistical Package for Social Scientists, which is now being used by scientists. Let me teach you a little of what? Data analytics. I did that, and guess what? This guy started making nothing less than about one day. He brought wine to my house, and he said, I just want to give you this. How much are you making? I asked. He said, 400,000 minimum is what I make in a month. I look at him, and he has so much developed himself into this data analytics to the extent that company were calling him. One day, a company called him and said, can you help us? We are having this rubber plantation, and we are seeing different yield of this rubber plantation. We want to know, based on their yieldedness, which one should we do? Which one should we use? And the guy was using data analytics to be able to help them in that particular research. They paid him very small amount of money because he had not been able to package himself very well. Because I knew if it's somebody like some other professors or whatever, they will overcharge those particular people. So again, it's application in data science. You are needed. I've been telling people quickly, go and study data science and data analytics immediately. And in master's degree, we do what we call chemometrics. More like it's the same thing that people that are doing statistics in business, statistics in economics, people call it econometrics. So in chemistry, we call it chemometrics. It's the same thing. Now, if you do it to that particular level that you are not just reading to pass, then you are knowing it to analyze problems. The first thing that happens to you is that people will be giving you projects to be analyzing first, and you'll be making money from them. Computational chemistry and modeling is another one that is coming up, whereby you use all the chemistry knowledge that you have, you begin to model it on a system, on a computer, and you can begin to use it to do what we call process chemistry and process instrumentation. And it's going to be so that if you don't have knowledge of chemistry very well, you won't be able to fit into that particular field. The same thing with chemical engineering and process intensification. Now, you would think it's only chemical engineers that are required. There are many places. I can tell you one of my students, Igwe, who graduated with first class, he was employed in an engineering company and is doing engineering work. When he met me one of these days and told me, sir, I'd like to visit you and I'd like to worship in the same church with you, On that particular day, I said, where are you working? He mentioned it. I said, you are working in NNPC. That job you are doing is typically an engineering job. He said, yes. As long as you have a basic knowledge in sciences, then when they begin to teach you what they expect you to do, you'll be wondering that there's nothing difficult about this. As a person that is talking with you, I was employed in the laboratory. Professor Adebomi happens to be my own personal, he came to the NYSC that time, if I'm not wrong, yes, in my laboratory, in the same company I'm working right now. In that same place, they transferred me straight to offshore. What was I doing there? Purely chemical engineering technician work. That's just what I was doing. So what am I telling you? They can pick you. You are not coming to say, this is not my field. This is not my this. I normally hear this one from lecturers. Don't give me that course. It is not my field. It's not this. No. In industry, they can pick you as a chemist, begin to turn valve. When you turn valve 50%, you hold on. What is going on? How much flow is going through this? By the time you begin to learn this, you realize that chemists can also be employed in that particular area. Science, communication, and education, of course, and that's exactly what we are doing right now. And you should be able to have the knowledge of what you are communicating and teaching to other people. Another area of where you can be working is entrepreneurship and innovation, turning research into startups and spin-off. This is common among those who are doing soap making and whatever you can call it. Tiny things they are doing in the world. And I remember Professor Adebomi at a particular time has also done some black soap and already converting into how we can use to do what? To start up a business. Now, that is to say, many people will be doing research and they will be bringing out some product. It is now left for you to say, go to people who can invest and say, sir, I want you to sponsor the investment of this particular research. And guess what? As a chemist, you are also going to what? Start making money in that. Intellectual property and patent law. You don't have money to do certain things, but because you have been able to do it, they collect it from you and they pay you. Funding and investment opportunities, collaborators and partnership can also be done. Let me quickly start and go back. Remember, I started with this traditional chemical science career, and I said I will only talk about two, so that I will give you a wider scope. The other ones I'm not going to talk about because of time. Let me quickly start that one. Under that traditional chemical science career, we have what we call research and development in the chemical industry. Under here, we have innovation, developing new products. There was a particular time in Nigeria, if I have to remind you, whereby if there is anybody that has malaria, they will use what is called chloroquine. Yes, chloroquine was able to treat malaria everywhere. All of a sudden, the malaria cluster started developing what we call, what was that? Developing, that's a word we use in science, whereby this particular chloroquine could no longer solve the problem of treating malaria. Then researchers have to go back into the drawing board. What do we do? Unfortunately, what we don't know is that the Americans don't have malaria per se. Why? Because the mosquito is not there. And the British don't have malaria. So we are not going to rely on their drugs. If there was a particular time we traveled abroad, and one of us that's working here, and he didn't know. He developed malaria when we went to, what was that country we went to? Was it Korea? And guess what? They quarantined him, and they couldn't solve the problem for one day to medical doctors who are expert. They brought in somebody to come and be checking. They say, no nurse should go near, blah, blah. I say, look at what these people are doing. So all of a sudden, we were able to get malaria drugs from Nigeria, flew it down there, and guess what? Within 2-3 days, even before the doctors will allow us to administer that drug, he collected the drug from us, went on internet and started checking one by one. Is he going to kill the person? We all laugh. At the end of the day, he solved the problem. Now, when chloroquine was no longer working, what did we do? Experts in Nigeria, experts all over the whole place, they entered into the laboratory. What else can we do to begin to work to bring a better? So whatever you are using today are the effect of innovation and developing new products. Things like Coartem, things like common malaria drugs that we are using these days, and it's because of the development of what? New product processes and technology. Competitiveness, sustainability, cost reduction. These are the areas research and development is crucial for all of us. I'd like to also mention research and development activities in chemical industry also include synthesizing and formulating, developing a new chemical product and formulations, process development, analytical and testing, whereby you analyze and you test a particular product. Many a times people said this herbs is useful. The part of chemists is so wide. These days that we are having, what was this thing that is so popular that people use in place of normal medicine? They will say, go and take this, go and take that. I'm trying to remember some of these common. Can you remind me of anyone? A common thing people are using these days, even if it's not drug, they will say is what? I'm listening. Can you hear me? Yes. Okay. I think I have to continue because I'm not hearing you as you are speaking. So, research and development, if you find yourself in that kind of a place, there's a fulfillment you'll be having. Why? Because many solutions of meeting people's problem, you are involved in solving that particular problem. So, research and development chemical industry is driven by not only to change product, is what drives the research and development in chemical industry. Number one, you can see customer needs and market demand. So all of a sudden, customers are no longer liking a particular product. They are now liking, if you can do it this way, if you can do that, then you have to be involved in that particular research. Regulatory requirements and compliance. At a particular time, if you throw this chemical in water in the stream, there is no problem. But the Nigerian NAFDAC or whatever study coming, environmental, Federal Ministry of Environment came in and started saying, no, if you are going to use this product, you will not allow you to throw into the water. Why? Because in the stream, they notice that it's killing fishes and this. Because of that, those who are producing that kind of chemical or product, they will have to now change their style and strategy because there is a new regulations in town. The same thing with technological advancement and innovation, and also sustainability and environmental concern. Global competition and market trend is another reason why people do research. Apart from that, research are also going in the following trend. There is digitalization in the industry, there is sustainability and green chemistry, and there is advanced material nanotechnology. Biodegradable and bio-based chemical are also one of those things that are now in focus. So if you are choosing research and development field, you can be rest assured it's so wide that you cannot exhaust it. Now, if we go to quality control and assurance, I love this. I've worked there before. I've worked in research and development, and I've also worked in this one. Quality control and quality assurance, they are critical in ensuring that products meet specified standard and regulatory requirements. And when you choose a career in this field, you'll be so happy that you are the one producing some of these particular products that is meeting the standard. Paracetamol contains 500 milligrams in a particular tablet. Now, your job in such a company is to ensure that my paracetamol is not 400 milligrams per liter or it's not 700 milligrams per liter, too much. It must meet exactly the standard. I'm not saying that whenever you are producing paracetamol, it's going to be exactly 500, but it's going to be between 495 and 505, something of that nature. So your job is to ensure that as they are producing the tablets every time, you will be checking once in a while. So some company adopt a method. Go there, pick the sample every 1 hour, analyze it every 1 hour, analyze it. As you are analyzing, you are recording the result and it's meeting the spec continually. Immediately the result is going too low or too high, you quickly tell the production guys, can you reduce the paracetamol powder? Can you increase this? That is what we call quality control and quality assurance. I'd like to quickly just mention the difference between the two without much ado. Quality control has to do with testing and analysis, and inspection and monitoring, and certification and documentation. Because of time, I will not go too detailed. I will send this package to Professor Adebomi, and she will send to all of you. Also, the key aspect of QC and QA in chemical industry is raw material control. There was a time, and I love this area, where somebody, I won't mention where he's from, he's a Nigerian, came to sell us paracetamol raw material. We were producing a particular product called Padox, which happens to be a paracetamol tablet. Just like we have Panadol, we have Enzo paracetamol, and many other ones. So he sold paracetamol powder to us. But immediately I got that paracetamol and I opened the bag. I smelled something like aspirin. And I told my boss, I said, I'm smelling aspirin here. And the guy said, no, it is paracetamol. Maybe we use the package for paracetamol for aspirin. I said, in the first place, why must you use that package to do this? No problem. So we pick it up. And when you are doing that sampling, you don't sample from the top. You sample from top, middle, we call it commingled sample, and you take it to the lab. By the time we analyze for paracetamol, guess what? Paracetamol content was about 20-something%, very low. Then somebody else, my boss said, let's just analyze for aspirin. Let's see what it is, because we're perceiving it. Guess what? Aspirin was what? 90-something%. Imagine that guy trying to sell aspirin to us as paracetamol. If we didn't do the QA/QC, we would have gone and start producing that, and we would have been killing people all over the whole place. So one of the key aspects of QA/QC is in raw materials what? Control. In process control and monitoring, I think I mentioned that one. Immediately production is going on, you begin to do what? Go there every 1 hour to be checking for this. Even the oil industry, where oil is coming from the sea into the land, we go there every time to take the sample, check for the salt content, check for the water content, and ensure everything is as supposed to be. The same with product testing. When we finally finish production, and they are sending this product into the what? Warehouse. Before you send it to be selling, the requirement of the entire Nigerian policy is you must still analyze that particular product. If it meets that, not only this time around, you will be doing chemical analysis and you'll be doing microbial analysis to ensure that that product still meets the standard before you send it out. Stability and shelf life. Some people think we only test for chemical content in tablets, for instance. No, in tablets, we check for not only chemical content, we check for what we call thickness, we check for dissolution rate. What does it mean if a tablet is given to somebody and it takes a very long hour, up to about 3 hours, before that tablet dissolves? That if you test dissolution rate, if you test thickness, you'll be able to know how long will it take for that tablet to dissolve so that it won't cause a problem for that person that is using that tablet. So when we talk about QA/QC, there are so many things that are involved in QA/QC, and the benefit of it can never be overemphasized. Improve product quality and consistency, increase customer satisfaction. It reduces error because you are checking every time. It will reduce error and rework. It reduces cost and improve efficiency. And like I said, these are the traditional chemical sciences career. These are research and development and quality control and assurance I have talked about. I won't be going into these two because of time and for you to go. I will also not be talking about this one. I will send the paper to you. Emerging fields in renewable energy, sustainability, biotechnology, all of them are in my package. I will send them to you. The same thing with interdisciplinary applications. I've mentioned the data science and analytics, how you can start making real money in this particular field already. Entrepreneurship and innovation. Many chemists are producing soap, are producing cream. People are producing perfume in a small quantity. And you wonder, one day I told somebody, it is good to produce perfume and you are mixing it together. I know, but there is nothing wrong in you extracting a perfume and oil from a particular leaf and you begin to synthesize it on your own. And guess what? You come out with a particular perfume that is not existing before. So you can always get funding and investment opportunity and collaboration from people when you have a brilliant idea like this one. Professional development and networking is another thing I would like to talk about. Building a stronger professional network, staying updated with industry and trends and advancements. I'm not going to be talking about effective communication and teamwork. I won't be talking about mentorship and leadership development. That is normal. Let me quickly talk about the building a strong professional network. Building a strong professional network is vital for career growth and opportunities. As a matter of fact, Professor Adebomi won't be doing what she's doing right now if she's not having a professional network with somebody like me, with somebody in NAFDAC, with somebody in the public analyst of Nigeria, with somebody abroad. That is when you begin to build a strong professional network. And it's very simple. When you have a robust network, it provides support and knowledge exchange and career advancement opportunity. When you do what we call staying updated with industry trends and advancement, I would like to talk more about this one because there is a particular gap between the academics and the what? And the industry. And one of my dreams is exactly what Prof is already doing. One of my dreams is very simple. I normally call it to bring the town with the gown being the university, the town being the industry. What can we do to bring this particular gap together? I will be showing you something. How do I combine industrial, permit me of that spelling you are seeing on the screen, it's a typo, and academic pathway? What are the benefits when you combine these two into what? To the student. Many a times we were taught to start doing only things on academic. But what I'm telling you now is while you are in the academic year one, by the time you go for holiday, look for one industry to start engaging yourself. Year two, holiday, look for one industry to get engaging yourself. I have a daughter that is studying in the university, is in year 4 right now. I can tell you, before that girl reached year 4, he has worked in many, many places and improved his work. Guess what? Now that he's in year 4, he's about to do a project that is interesting to the industry. Why? Because he was combining the two right from year 1, year 2, year 3. What are the benefits to the students? 1, it improves employability. You don't just graduate as a chemical science degree holder and you just come out and think you're a fresh graduate. No, they would definitely prefer someone who has both combined degree, academic, and also what to industrial. 2, it enhances career options. Yes, while you are growing in these particular 2 pathways, you begin to think, should I go here? Should I go here? You have too many options to do what to choose from. 3, it increases earning potential. You can be working on this one here and be doing another thing on the world. Well, some of you call side also. Yes, you can be doing that. 4, it's a better solving skill. When you combine the 2, you'll be able to do so many things. At the end of the day, you'll be able to solve problems that people in the university cannot solve just because they are only concentrating on what we call academic pathway. You are able to solve that particular problem because you have the 2. It increases your motivation, and not only that, greater flexibility. You're not just rigid. If it cannot be done this way, then it can be done. And I'm going to tell you something that's happening all over the whole world. You would think it is only in the university that they are doing research. Unfortunately, the industries also have research and development units whose work are even higher in terms of findings than the one in the university. Why? Because they have the resources and they bring the best brain all over the whole place to do what? To sit down and solve problems. They may not publish it to the whole world because it becomes something patent that they will be using. And therefore, there is a need for us to be leveraging on these particular people and be gaining something from it. It reduces skill gaps. Additionally, it increases innovation, better preparation for the workforce. Imagine you starting your degree both in the bachelor degree and the master's, and you are combining the 2. Guess what is going to happen? You will be able to do what? To better prepare for the workforce that is coming ahead of you. Enhance personal growth, reduce prejudice, and guess what? It improves confidence and what? Inclusivity and collaboration whenever you are combining academic pathway and the industry. It makes you to have critical thinking and open-mindedness when you're able to do this. Permit me to say, the key focus here is cross-disciplinary project. Anytime you want to do a project, begin to think not only, I remember those days whenever we want to do projects in chemistry, you say, go and synthesize 3,4-dichloromethane, 3,4 blah, blah, blah. Why are you synthesizing? And those are abstract. Today, they have encouraged chemists to go to the industry, ask them what problem are they having, and they will mention it to you. Come back to the into the academics and begin to see how you can solve that problem for them. And guess what? You will be fulfilled. Not only that, that particular industry can pick you immediately to come and be doing something. And that's what I call industry partnership immediately. Additionally, the industry partnership and other area can be involved in what? Teacher training, internship for postgraduate students, and apprenticeship for training. What do I mean by this? Anybody that finished master's degree or bachelor degree and you have finished your youth service and you don't have anywhere to go to, and I'm only advise, very simple, write to any industry that you would like to come and do internship. Some will pay you, some will not want to do what to pay you. I have admonished and advised people, go to anyone. If they don't pay you, at least within 1 year, especially if it is closer to your what? Your place of residence, you can just go there to tap. In just 6 months, if you're able to solve problem for them, immediately you say you are leaving, they will quickly say, hold on, we're going to pay you. So I advise people not to sit down at all. There are a lot of things you can do and merge with the what? Industry. You can develop your skill, you can do professional degrees, and so many other things that you can bring together. Additionally, I like to tell you some of my personal true life story that I had. Networking and building relationships that I did in my work, chemistry world as an academic. Presently, I'm working where I mentioned before. Not only that, I'm also lecturing in the university, and I've been lecturing for the past 13 years, and I do that lecturing for free. Why am I doing that? I'm trying to solve problems in the academic world and in the industry world and combining the two together. I would like to let you know that most students normally appreciate my bringing industrial experience into the class because they are able to understand it deeper than when I'm just using diagrams in the books only to explain to them. There is a particular lady in my university who finished physics and didn't know why he finished physics. And guess what happened? Hold on, please. Just 10 minutes, 15 minutes. Sorry about that. And when he finished his degree, he told me, I don't know what to do. I said, no, don't worry. Do you even know the physics you study has so many applications? He doesn't know. And I said, okay, let's go to so and so place. I took her to where they call a code house, where they will be teaching her electronics and instrumentation, hands-on. By the time this lady finished this particular training, a 6-month industrial application training, he now went to do one interview in Abuja. She came back and said, doctor, even though they didn't pick me for that interview, you have made me to know why I've gone to the university. Right now, my own first daughter finished degree in engineering. I told her, you cannot go and do anything yet. You must go and study and start learning some, what we call skill acquisition. I'm not talking about skill like hairdressing. I'm not saying it's not right, but I just told her, go and do industrial automation, go and do this, go and do that. And guess what? That training cost 4.something million naira. But I'm not afraid. I didn't pay the money. I was praying, I was looking for what something opportunity came for somebody to be able to sponsor that particular training. And guess what? My daughter said that training is so voluminous and she's getting it, she's doing it. Now, guess what? Immediately she finished that particular training, what is going to happen? She will get jobs because people are looking for those who have this kind of work, kind of skill. So I am encouraging you to do what? To go into this particular skill acquisition training, whereby has to do with industry proper. And that lady later is improving on her life. There's this other thing happened to me as a person. I maximize my time, evening industrial analysis and the onshore academic. I mentioned that one to you earlier, whereby I'll be going to teach in the afternoon, and I'll be in the evening, I'll be doing evening chemical analysis. I didn't know when I later applied for this oil company job, the first question they asked me is that, you say you're a teacher? I say, yes. Where did you get this experience from? I say, I normally go to in the evening to do this particular laboratory experience training. And that is one of the singular reasons they tick me right. I say, yes, you are not sitting down only as a teacher, you are also developing yourself in other areas in my chemistry field. I would like to also quickly tell you that The last thing I put here is what we call volunteering. When you don't get a job immediately, volunteer to go and help, volunteer to support a particular industry, volunteer to do this. They will gladly pick you. Some good industry will be giving you stipends for your transportation. But when they see how good and committed you are, you'll be so surprised that that job you are looking for, you will quickly get it in a platter of what? Gold. Finally, I'd like to let you know so much advancement in research and development in the industry, most of which are not published. I mentioned that for the public, though all the documented within the industry due to data protection. Only those who do sabbatical from the university and find themselves in the industry normally have opportunities to add this to their academic knowledge. I would like to let you know, when I did my PhD, it was difficult for me because I exposed metal to the atmosphere to corrode, and I wanted to know the level of corrosivity. That the only thing is I have to remove the corrosion, the corroded product. How will I remove it without touching the uncorroded metal? It was tough for me. I look at all the academic method they use. It was difficult. If I should attempt it, that metal will be touched. I started thinking, and I came across an industry whereby they use reverse electrolysis to be able to do what we call to save the cathode, and to the anode has to be destroyed. I quickly used that same method to this particular metal that had corroded. Guess what? Only the corroded products were removed, and I had the metal. Where did I get this experience from? If not what they were using in the water, in the industry. I want to let you know that industry is so wide for chemistry, and whatever you are just exposed to is just a miniature of what is existing in the entire world. I'd like to stop at this junction and say thank you for making me to give this opportunity to speak to you at this level. Thank you very much to all of you. Any questions so that we can round up?
Yes, sir. Yes, sir. So we're waiting to see if people will indicate if they have questions. Does anybody have any questions for Dr. Clement Obadimo? Anybody? Prof, you don't have any questions, sir? That's new. Emanuela, no question. That's also very new. Any other person? Well, we don't have any, there are no questions, but what we can do is if anybody has any other questions, we can just pen them down and send them to you through Professor Ikotun, and hopefully we can get those responses back to them if that's all right with you.
Thank you so much. I'd like to step down. Since there are no questions, I'd like to step out. Thank you so much, all of you. Thank Professor Ikotun for the opportunity. I appreciate. I want to drop this. I shared something with my daughter of somebody I met who said is collecting very big amount of money for being a consultant in an industry. There are too many opportunities I want people to make. When you finish your degree, don't sit down. Start engaging industries, even if it's going to be free, and developing yourself. For somebody to be collecting $2,000 per day and someone collecting $160,000 per day, don't say it is a lie. I have some of these people, I have met them before. So I want you to start developing yourself in such a way that when you finish, start doing what we call industrial connection, so that within 2-3 years, you are there as a consultant and you'll be collecting something bigger than you can imagine. Once again, thank you for the opportunity. God bless you.
Thank you, sir.